All right, here we are a problem that we need to use the Kirchhoff's laws in order for us to solve the problem. The first one is that you are asked to state what would be the relationship between I1, I2, and I3 using the first law of Kirchhoff's. So if you look at here, this is where the junction where I1 enters, and as you notice that I3 and I2 are both moving away from junction A. That means that if you combine I3 and I2, it should be equal to I1, and that's the first law, where whatever current enters in one junction should be equal and opposite for those who are leaving the junction. So that gives you I1 equals to I2 plus I3, and that would be the statement. Now here, you are asked to calculate for I1. Now, there are actually two approaches that we could use in order for us to calculate I1. We can actually use the regular approach where we simply find out the total resistance and solve it using the total voltage. 12 volts is the total voltage because I1 is your total current. Okay, or we can use this relationship and identify what is I2 and I3 so that we can get I1. Okay, I'll show you both. Okay, first approach to this. So you simply find out what is your total resistance first. So R total is equal to 1 over 6 plus 1 over 10. Reciprocate. Okay, where did I get that? It says here that wire AB has a resistance of 10 ohms. So this is 10 ohms. This whole thing is 10 ohms. This one, on the other hand, is separated in series connection, but if you add them together, becomes 6. So this becomes 6 ohms. This is 10 ohms. Since they are parallel to each other, add them in parallel. So that gives you 1 over 6 plus 1 over 10. Then reciprocate the value. Wait. Then you'll get 3.75. Okay. Now, as you get 3.75, solve for the current, which is voltage over resistance. That's 12 over 3.75. 12 divided by 3.75. And you will get 3.2. Okay, that's your final answer. So that's the other way. Now, if you're using the Kirchhoff's and using this relationship on top, find first what is the current in the middle part. We know that this is, what do you call this? This is 10 ohms, right? And this is 12 volts also because they are parallel. So I is equals to 12 over 10. Then that gives you 1.2. Okay, this is I2. Then I3 is 12 over 6. That gives you 2 amperes. Okay. I2 plus I3 gives you 3.2 amperes. So that is the answer for that part. Okay. Now let's move on to the next question, which is this one. Calculate the potential difference between the points C and D as shown in figure 5.1. The distance AC is 40 centimeter and D is the point between the two series resistors. Okay, so if we're going to go back here, we want to find out what is the potential difference between C and D. Okay, how are we going to do that? Remember that if this total here is 10 ohms, then it's safe to assume that this should be around 4 ohms only, right? Okay, if that is 4 ohms, then this is also 4 ohms. We can now solve for um the value, the voltage, right? I think that's what they're trying to find out. So we need to find out the voltage here and find the voltage here. Then we can subtract the two values. Okay? Okay, so we know that the current that is moving along points A to C is equal to um 1.2 amperes, right? And the other one is 3 along the 4 ohm resistor is equals to 2 amperes. From here, we can already solve for the potential difference along that area. So if A to C, that's equivalent to 40 cm, that is equal also to 4 ohms. So from here, we can solve for the voltage. That's voltage equals to 1.2 ampere times 4. That's equals to 4.8 volts, right? Then this one, we simply use the 2 ampere, okay, multiplied by the 4 ohms. That gives you 8 volts. Okay, subtract the two value, 4.8, 8 minus 4.8, and you will have 3.2 volts. So this is now your answer for this question. This is how you use your Kirchhoff's laws.